Okay, so here is a review of weather. Now, here are the main facts that we need to know. Warm air rises, cools, condense, and form clouds. Right? So this is fundamental. We have to know that warm air rises, cools, condense, and form clouds. Now, condensation is the phase change from gas to liquid. Warm rising air cools down to the dew point temperature. And the dew point temperature is the temperature at which condensation begins. So all of these facts, they all go in hand to hand when we want to talk about weather. Okay, so warm air rises, condense, cools, condense, and form clouds. Condensation is the phase change from gas to liquid. Warm rising air cools down to the dew point temperature, and the dew point temperature is the temperature at which condensation begins. So here's a typical reasons question. It says the incomplete flow chart below shows some of the changes that occur in warm air as it rises to form a cloud. So if you go along, warm air rises, then the air expands due to lower pressure. This is what we want to know. Condensation occurs and form clouds. So which statement should be placed in the empty box to accurately complete the flow chart? So here's our choices. One, warm air, the air warms as it expands. Two, the air cools until it reaches the dew point temperature. Three, the air's relative humidity decreases to zero. And four, the air enters the thermosphere. So if we go back to our facts above, the best choice would be two. The air cools down until it reaches the dew point. So warm air rises, the air expands due to lower pressure. The air cools until it reaches the dew point. Condensation occurs and clouds form. Right, so here's a diagram again. Warm air rises because it's less dense, it has a low density. So anytime they ask the question, why does warm air rises? It's because it's less dense. Colder air is more dense. So that's why you have cold air sinking down. So here's a diagram right below here where they always ask, they tend to ask this question. You get a diagram where you have a mountain, the air going up against the mountain, and then you have the formation of clouds. Okay, first we need to understand uh, the names, some of the names associated with either side of the mountain. First, the side where the wind is going towards the mountain is called the windward. Okay, the windward side of the mountain. On the opposite side is called the leeward. The leeward side of the mountain. And typically they'll ask you the type of weather conditions or climatical conditions on either side. On the windward side, it tends to be cool and moist. Okay. On the leeward side, it tends to be warm and dry. The air expands. On the windward side, and it contracts. On the leeward side. So this is something that you should be able to recognize when it's asked. So here's a typical reasons question. The diagram below shows air movement over a mountain. So we have our cloud formation. So as the air is rising, it cools, condenses, and it forms cloud. So at some point, it reaches the dew point temperature. So compared to the climate on the windward side of the mountain, the climate on the leeward side of the mountain is, well, the choice is drier, 1, drier and warmer, 2, drier and cooler, 3, more humid and warmer, 4, more humid and cooler. The best choice here is choice 1. It's drier and warmer. The moisture doesn't reach over to the leeward side, and as the air is coming down, the air is being compressed. And as it's being compressed, it's being warmed.